Good afternoon, students. In today's class, we will learn about what is the feedback and what is the effects are. So, feedback plays a very important role in the control system. As we all of know that feedback plays a very important role. Now, what are the effects of feedback also should be learnt in the today's topic. That a feedback is always introduced to reduce the error in the system, Now, what happens if the error is there in the system? If the error is there present in the system, then we will not get a proper output. What a desired output will not be got. So, what we do is we have to reduce the error. So, we are using the feedback loops. So, in this feedback loops, whenever we are using a control system, if the feedback is properly designed and properly connected to the system, then we will get a desired result, and therefore the control system works with the good efficiency. So, coming to the point directly, here we have to focus on the system, that the feedback, if it is being maintained in the system, then we can also get good results on some factors that are called as stability, bandwidth, sensitivity, overall gain, and these are the main factors. Noise, disturbance also reduced, So, these are the 5 factors that are stability, bandwidth, sensitivity, overall gain and disturbances. So, these are the factors that are affected by the feedback. So, to control these stability, bandwidth, sensitivity and overall gain and disturbance, then the system will be a perfect system for controlling purpose. So, we will go into this stability and bandwidth, sensitivity, overall gain, disturbance all one by one. So, before going one by one to this topic, first we have to understand that how a single loop feedback is going to work. And what is the gain there, we have to understand first. Okay. We introduce the feedback into system for improving the performance of the system. When we introduce this feedback for improving the performance, then we have to remember some factors. That these stability, bandwidth, sensitivity and overall gain should be considered in that one. And also, whenever we see some non-linear systems, or we see some systems which are having no feedback, non-feedback systems, they are also having a feedback. When we carefully observe it, we find that there is some feedback system existing in that. Like we are having some cause and effect relationship in the system. So, I will tell you one thing, that whenever effect has happened, that there might be some cause, if effect has happened, there might be some cause. So, if nothing but if we change the cause, then the effect also will change. Nothing but there exists some feedback. Definitely there exists some feedback in some inherent non-feedback systems also. So, it is a good thing that we have to carefully see that our feedback systems improve the stability and the performance of this system. So, we will first of all see what is a single loop feedback system. And again we will see the double loop feedback system, how the stability will be increased and how the stability can be from unstable to stable, how it can be brought, we can see in these topics. Okay. So, if you draw here feedback system, with one feedback loop, then we will be seeing here a system that is having a comparator, and also we will be having g of s here, and C of s is given here, and is the RF is input, and here you will be having plus and minus. So here H of S is the feedback, as you all of you know that H of S is given as the feedback. So in this feedback system with one feedback loop. Here you will be having M is equals to C by R, M is equals to C by R, that is equals to G of S by R, you can write G by 1 plus GH. You can write G of S by 1 plus GH, in short form also you can write G by 1 plus GH. So M is equals to G by 1 plus GH. So here we can say that we can now study about the what is how the parameters that are discussed about the stability and also overall gain and also bandwidth, how they are varying. We can discuss now by having this formulas here. Okay. Here we can also say that this is the input-output relationship of this figure, particular figure. We are having the input-output relationship, that is M is equal to C by R or G by 1 plus GH here. Now we will see what is the effect of feedback on overall gain. If you come to this point, we can say that the overall gain is affected by 1 by 1 plus GH. It is affected by 1 by 1 plus GH times. It is being varied. The gain is being varied. Here, G and H are the terms which are linked to the frequency. Now, if GH is minus, then the term 1 by 1 plus GH, 1 by 1 plus GH is becoming 1 by 1 plus GH. If it is both are negative, or if one term is negative here and this is 1 minus 1, that 1 minus 1, it will be 0. So it will be 0, nothing but it will be infinity. So it will be infinity means the system will not be so stable, it will become unstable system. So in this unstable system, you have to see that the gain should be properly observed, that it should have proper gain. Okay. So the overall gain is affected by the 1 by 1 plus GH times. So we can conclude that the effect of feedback on overall gain is such that it can be negative for some frequencies and positive for some frequencies. Like overall gain, if you see that the 1 plus GH is their term. So here it can be varied. From one frequency it will be minus, and for one frequency it will be positive. So the overall gain may increase or overall gain may decrease for some frequencies, and for other frequencies it may decrease or increase. Okay. Next is effect of feedback on stability. So effect of feedback on stability is nothing but if you have a system, how do you say that system is stable? If the input command is being properly received and the proper output is given, then it is said to be a stable system. If there is some disturbance or there is some output is not proper and therefore the input command is not taken properly by the system, that system is said to be unstable system. So mathematically, if you want to say, in the figure 1 you have seen that the first one figure what you have done, single loop control system diagram there. In that diagram, if we have already seen that M is equals to 1 by 1 plus GH. M is equals to, we have seen that it is G by 1 plus GH here. G by 1 plus GH. In that, if here GH is negative, so it is negative, as I told you already, that it is equal to G by 1 minus 1. If GH is negative value, so it becomes G by 0, nothing but infinity. So if m is going to be infinity, then what happens is, if the infinity value is there, then the system is called as an unstable system, and that cannot be easily controlled, So in this type of systems, we have to introduce one more feedback loop we have to introduce. Like we have seen a single feedback control system, in that only one loop was there, and now we will introduce a double feedback loop system, where you can improve the stability of the system. So just now we have seen that the system has become unstable. Now we can also implement one more feedback loop. What this is, this loop will become the inner loop, and the outer loop will be a different one. If these two loops are there, if the inner loop is unstable also and the external loop is stable, then the system will be stable again. So if introducing a feedback in a system is nothing but to improve the stability, it can make an unstable system to a stable system, and also if not used properly, it can make a stable system into an unstable system also. So the effect of feedback will be more on the stability of the control system, as we have already known in our this explanation, that how the system becomes unstable. GH is equals to -1. If GH is equals to -1, if we substitute here, then this system becomes unstable. If you want to make the system stable, again you have to introduce one more feedback loop, and we will see the diagram of that. This is R of S, and this will be your C of S output. These are the feedbacks. H of S is a feedback, and as well as F of S is also a feedback. So it is your two loops. Two loops of feedback. So we are having how many comparators? 1 and 2 comparators. This is the inner one, where we are having the G of S function, and here we are having the feedback. And we did just now talk that this is going to become unstable. Then if this system, this other feedback loop system is going to enter here, and this will be correcting the system and giving the correct values to it, to make the overall system to be a stable one. Okay. So what we understood is, here the stability is a double-edged sword. If not used properly, the system can become unstable. If used properly, the system can become stable, and it can be very helpful in making the system to be more efficient. And here the input output relationship, as we have already drawn the input relationship, C by R is equals to G by 1 plus GH plus GF, like this, G by 1 plus GH plus 1 plus GF. So this is going to be our input output relationship for a two loop function, two loop feedback system. Okay students. So here it is effect of feedback on disturbance or noise. So in all the general physical systems, we will be seeing that we are having some disturbances or noises. Like whenever you go through an antenna over your building or somewhere else, you will see that the wind gusting sound, wind gusting noise will be affecting the system. And also in the electric motors, you have seen that the brushes will be making some sound. That is also an external noise, which is being considered as a disturbance, and also we call it as a noise. Also we call noise means nothing but it is a disturbance. And one more thing is whenever you have some electronic circuits, it is called a thermal noise. Thermal noise of electronic circuits is also treated as one of the disturbance for the system. How? Now we will see how the feedback will affect the disturbance or noise. Now the feedback should be in such a way that we have to properly reduce the noise in the system. So we will see that how the design, first of all we have to take care of the design of the system. If the design is proper for the system where it is insensitive to the noise, nothing but if you are having noise also, it is insensitive means it does not affect the stability or it does not affect the system performance. So the system should be designed properly beforehand only. Using the new technologies, you can design a system where some noises will be eradicated or it can be removed from the system itself. Okay. So we are having this diagram for this also, where we can how to reduce the noise for the systems, and we will see that how the noises reduced means how the system will be working properly. Okay. So if you see that this system effect of feedback on the disturbance or noise, this is the circuit diagram for it. Feedback system with noise signal here. Here we are seeing that the noise signal is introduced here at the comparator, and these are the G1 and G2, and this is the feedback called H. So it is a reference input here, and this is the output. As we see here, how does it affect the stability? How does the noise will affect the stability, and by what factor does it affect the stability? We will see by the equations here. So we will be having some equations for this particular control system, and we will write the equation one by one with feedback and without feedback. Here C is equals to G to N is one equation. When we are having without feedback here, without feedback, and with feedback, the equation written to this particular diagram is written as, we will write this equation as C is equals to G1 by 1 plus G1 G2 into H. G1 by 1 plus G1 G2 into H. So here all the functions we are seeing that are from this diagram only here. So here this is without feedback and with feedback, how the system affects, how the system gets affected. We will see here. So by seeing these equations, we can compare that these two equations, G1 G2 into N and G1 by 1 plus G1 G2 H into N. We can say that this G2, if it is there, we can say that the feedback is going to be affected by so this is we easily compare here, this is G2 and this is also G2. Now it is 1 by 1 plus G1 G2 H times 1 by 1 plus G1 G2 into H times. So if you compare both of these equations, you can say that the difference is G2 is same here, G2 is same here, N is there and here it is also there. So if you compare it 1 by 1 plus G1 G2 H times, the noise will be reduced. Noise will be reduced 1 by 1 plus G1 G2 H times, and the system should be kept stable at this particular time interval. Okay, and if the system is kept stable without any disturbances, then we can say that the noise is being reduced by the system. Okay. So effect of feedback here on the sensitivity. We are talking about the sensitivity, effect of feedback on sensitivity. So for sensitivity, M is here the overall gain of the system, and here is the G is the gain parameter, and with the variation in the G, how this particular sensitivity is having its effect on the overall system, that is overall gain of the system M. We will be writing dou M by M, and that is whole divided by dou G by G. So percentage change in M, what is the percentage change in M by percentage change in G is nothing but the sensitivity of the overall system by the some gain variation G. So if you write S M suffix and prefix, here you can write that SMG, that is equals to dou M by dou G into G, into G by M is equals to 1 by 1 plus GH here. So 1 by 1 plus GH. So as all of you know that GH is the function of frequency, and also the sensitivity is also having its change in the system. Whenever a system is there, we have used in a period of time, its sensitivity also changes. Its sensitivity also changes because now we will see that due to environmental changes or electric motor is there. If you are having some current given to it, the temperature rises. The temperature rises and the winding resistance are also will be changing. The winding resistance also will change accordingly. So depending upon all the parameters, the sensitivity also keep on changing here, and we should see that the feedback of the system will be helpful in maintaining the sensitivity of the system to the external parameters. So it also depends on the parameters, what parameters are being changed by the external disturbances, like environmental changes will be having some sensitivity issues, and some other factors, temperature will be having some issue over sensitivity. So what parameter is there actually for defining the sensitivity of the this particular control system? So we generally take a closed loop control system. In the closed loop control system, by the effect of feedback also, how the sensitivity is being changed, we will be calculating like this: percentage change in M by percentage change in the G, and it will come to 1 by 1 plus GH. Okay. So we will do some problems on this overall stability, and also this overall gain, and also this bandwidth. We will be considering all these terms, and we will see that how the closed loop control system is going to affect all these in some problems in the coming classes. And now I end this lecture, and we will be continuing in the next lecture about some mechanical control systems, like different types of control systems are there. So we will be learning about and doing some problems in the next classes. So I conclude here, and we will be taking the next class tomorrow.